All right, on Friday we finished up our notes and our spiral that went with our net. We had a square prism here, a net of a prism, and we did the area of the squares, and we talked about lateral area, and we labeled like the edges. That was our blue line. A point where the edges meet, that was the vertices. Just a recap basis have to be the two congruent and parallel shapes. And we also showed which was the lateral face. That was everything in between the bases. Okay. And so then what I have up here, I'm just going to kind of highlight key information or underline key information. A prism, you don't really need to know the technical definition, but we do know that the congruent faces are also going to always be called the base. So because the two squares, all squares are congruent, so because we have two squares, we know those pieces would represent the base. And even if I kind of outline it here, here are the base. Okay, and they're congruent and parallel. And then everything in between the bases, so my polygons, our parallelograms here, all this was our lateral face. I think we maybe label just one, but just understand everything here. Okay, so we have what we call lateral area, which is the area just the lateral faces, and we have total surface area, which is all the faces. Another thing we looked at is surface area is the sum of the area of its face, and then the formula. So I do need you to write down S equals PH plus 2B. I understand that P is the perimeter of the base, H is your height, okay, of the prism. Height of prism. And then we have B. Our capital B is always area of the base. That's why knowing that shape, identifying that part, is important to get all the other calculations correct. So from there, we looked at volume. Volume is the measure of space, cubic units, basically, inside a figure. So we're trying to think of how many cubes we could fit in the figure. V we're going to use for volume. The formula for a prism is V equals B times H. B is the area of the base. H is your distance between. So I just put the two B's to show the base. We need to find the area of one of the bases. So if I did that, the area of this base would be 16. And then the height, this is the units between the bases. That was 6. So the volume would be 16 times 6. Which would give us 96 cubic units. So we went ahead and calculated the volume of our prism. And then we went to our square pyramid. And on our, let me go back to our net real quick. On the net, we went ahead and we calculated this area was 16. We saw that this was 4. I probably should do that in a different color. But yeah, sorry. We had a 4 by 4. So we knew that this edge was 4. And then we could see the height. Height's always perpendicular. That height was 1, 2, 3, 4, 5 units. So we had a 4 by 5. But the area of a triangle is base times height divided by 2. So we had a 4 by 5 divided by 2, which made each of these 10 square units. Okay. So we did that. Then we also, let me go to the base in a pyramid. You only have one base. Okay, that was our B. Our lateral faces in a pyramid. Your lateral faces in this pyramid, for example. Can we get a highlighter, please? There we go. Are the triangles. They're always triangles. For pyramids, your lateral faces will always be the triangles. So you can say equals to triangles. And then your edge, remember, your edge are where the faces meet. Okay, your edge could be, I know this is kind of, is where the faces meet. So what I wanted us to look at a little bit was, so showing the net being formed. Let's close that. So, for example, if I had this, let's go to a pyramid though, because that's what we're looking at right now. So here's our rectangle pyramid. I can slow this down so we can see. And then what they're showing you are all your faces. You can rotate to see that. And then we have basically the net. What I want you to see is that this edge will always line up. So when we're looking at the net of the pyramid, we still need to know the edges, the line segments that would meet when you fold them. Okay? So basically, we went ahead and labeled our edges, or I gave an example of an edge and a vertex. And in a pyramid, they meet at a common vertex, which we call the vertex. So here's our vertex, here was an edge. And we were fine after that. Now, this is just a form of definition. Pyramid is a polyhedron, on which the base of the polygon and the lateral face is always triangles. That's what we already talked about. Now, I do need you to write down the formula for surface area. We have to understand a new little term or relationship, and that is B, you already know, is the area of the base. P, you know, is the perimeter of the base, but this L here, this is what we call the slant height. And so you might want to understand that the slant height is also the height of the pyramid, of the lateral face, excuse me. Not the height of the pyramid. The height of the pyramid goes from the center to the vertex. But because we had already, on the squares, we had already drew our height of our lateral face of our triangle, please understand that that also represents the L, which is what we call the slant height. Okay, our slant height. So your L, your slant height, will always be the height of the lateral face, which is the triangle. Okay, and then we had a formula for volume. Here, volume is 1/3 the base times the height, or you can look at it as the base times area of the base times the height divided by 3. So if you understand that's what it means by taking a third or something, you could do that. B is still the area of the base, and H is the height of the pyramid from the center of the base to the vertex. So make sure H, your height, is from the center of the base to the vertex. All right, so then we looked at some examples. We also went ahead and add the fact that the altitude, another word for height is altitude. So went ahead and addressed that. Right prism just means that perpendicular to both the bases. You got to see the box, basically. And then for an oblique means it's not equal to 90 degrees. So basically it's leaning, okay, to the left or right. We have to have some type of lean. And then we have a slant height and oblique. That's also your lateral edge. So if you wanted to trace this, you could. It wasn't really that. Just kind of getting you familiar. Same thing with a pyramid with the lateral faces, or the lateral edges, excuse me. So you have lateral face has a lateral edge, and then we also have our edges around our base, okay, which connect to the lateral faces. And then we have our slant height. So our height, or our altitude of a pyramid, is our distance between the base to the vertex. And then polyhedrons. Basically, polyhedron has no curves, no circles. Okay. has to be made up of polygons. The faces have to be polygons. So you could copy down this definition, pause the video if you need this, because I'm just going to kind of address it real quick and then move on. So just understand it's a solid that's bounded by polygons. The edge of the polyhedron is line segments, and the vertex is a point. And then we had these formulas. You can pause the video too to get these formulas down. They're on the formula chart. You don't have to memorize them. We're just talking about because it's V equals BH. What if B is a circle? Then you just substitute pi r squared for B times the height for a cylinder. All right, and then this was our first examples. We had a total of, I think, 6 examples that we're going to do. And if you didn't get this guided practice, basically it was called a guided practice, the surface area and volume worksheet that we added to the notes after the nets. If you don't have this, just draw it, add it to your notes right now. All of the guided practice are test-like. And so they want us to find the surface area. So it's right here, find the surface area of the regular hexagonal pyramid as shown. So if I'm trying to find the surface area, I do SA to do surface area. They're talking about the total. And I start off with my formula, 1/2 PL plus B. So we just have to recognize what the P is, what the L is, and what the B represents. So P is your perimeter of the base. So we have to start with recognizing or understanding the perimeter of the base. The base here is a hexagon. So basically, I'm taking this hexagon that I see. This is our base, our B. This is our B. And I know each side is 6. So the perimeter of the base would just be 6 times 6, which is 36 inches squared. And then I need the L, which represents the slant height. Now, I'm going to draw the slant height. I need you to draw it with me. But it goes from the edge of the base through the middle all the way up to the vertex. It's perpendicular. So I'm going to draw an arrow to that L. And I need you to understand that it is the height of the triangle. So if I was just to look at just this triangle, so I'm going to go back now to just the triangle. The parts I can label, 1, I know the edge of the hexagon, the side of the hexagon. It's also going to be my base of my triangle. So this whole base is 6, but it gets bisected because of the height to 3 and 3. And I'm still trying to find my L. I'm going to have to calculate the L because it's not given. The 5 that you have given, this 5 on the pyramid is what part, or what does that segment represent? This is your edge, okay? All right, so that means I can put it over here. It's also the leg of the triangle. So in order for me to find my L, my slant height, I'm going to have to use Pythagorean theorem, or we're going to see that we have a triple, okay? Because I would do L squared plus 3 squared equals 5 squared. I think some of you might have already saw it, that the slant height L is going to be 4. So now I have my L. The only other thing I need now is B, the area of the base. And so my area of my base, capital B is the area of my base, and my base is a hexagon. So that's when I have to do apothem times perimeter divided by 2. When I apothem, we need to calculate, which hopefully we can see that anytime I have a hexagon, only for a hexagon, okay, only with hexagons. This is a fact you need to memorize to help you problem solve a whole lot faster and better. The A is whatever the side is in the hexagon divided by 2 times the square root of 3. So since my side is 6, I'm going to take half of that. So that's going to give me 3 square root of 3. That's my apothem. My perimeter I've already calculated. That was my 36. And then we're dividing by 2. So I'm just going to simplify 3 square root of 3 times 36 divided by 2. And I get 54 square root of 3. So that's my B. So all I'm doing now is plugging it into the formula. Surface area is 1/2 my 36, which was the perimeter, my 4, which is the slant height, plus my B, which was 54 square root of 3. Okay? So if I simplify this, half of 36 times 4 leaves me with 72 plus 54 root 3. This right here is the exact answer because 72 cannot be added to 54 root 3 because they don't have the same radicand. They don't both have a square root of 3. But if I put this in the calculator, that would give me my approximate answer. And I think this is approximately 165.5. And that would be inches squared. Okay? So that took care of the example dealing with hexagonal pyramid. And we did that shape because you're going to see a hexagon again still. Then we looked at a cone. So this is some facts that you need to know about a cone. It's a solid, it has a vertex, and it has a slant height. Okay? The altitude or your height are the same, and it's perpendicular distance between the vertex and the base of the cone. So we're now going to just make sure you understand that this edge, not really edge, this is your slant height. All right. Hopefully this came out all right. Okay, so example 2, since the ladder of a right cone is 180 centimeters squared. If the slant height is 15, find the radius, the height, and the total area. So we need to find this radius using the formula for lateral area. LA, which is lateral area, is pi RL. Pi times the radius times L. And so, since I already know that the lateral area is 180 pi, I'm going to put that 180 pi here for lateral area. And I know this 5 represents, or 15, excuse me, this represents the slant height. So, I'm trying to find the radius. That's my R times 15. Now, I've got to work backwards to do that. I'm going to divide everything by 15 pi so that they would cancel out, leaving me just the radius. The pi's will cancel out, 15 will cancel out, and right here the pi's will cancel out as well. 180 divided by 15 will give me 12 is the radius. Okay, so that's our radius. Then we have to find the height. So once I put the 12 in for the radius, oops, I did 15, sorry. Then this would be the height from the center of the base to the vertex, and I would use the right triangle to find that height. And that height is a triple, but you could do h squared plus 12 squared equals 15 squared, and then work backwards, and you should see that the height, because it's a triple, is 9. So the height is 9. Just a minute. Sorry. All right, so we got the height, and then they want us to find, the last thing they want us to do is find the total area. So to find the total surface area, our formula is pi RL plus pi R squared. And so we already know the lateral area because that's the pi RL. That was 180 pi. All I got to do now is do pi times the radius squared, which was 12 squared. So it's 180 pi plus the 144 pi gives me a total surface area of 324 pi. and that would have been centimeters squared because it was centimeters for the height. All right, so that's example 2. Then we have another hexagonal prism dealing with the hexagon, and now they want us to find the volume of that. And to find the volume, our formula is BH, area of the base, times the height. Now, our base are the 2 hexagons, because those are 2 congruent shapes. So we need to focus on this hexagon. It's a regular hexagon. Those tick marks tell me so. Okay, so these are my 2. I just need to find the area of one base. And to do that, I'm going to have to do my B as apothem times perimeter times 2. I'm going to divide by 2. Our side in this hexagon, the side that we have is 4. So we learned, or we hopefully remember, that to get to the apothem, we just take half the side, radical 3. So the side is 4, half of that, that's 2 radical 3. That's my apothem. My perimeter, there's 6 sides times 4. That gives me 24. So I'm doing 2 times square root of 2 square root of 3 times 24 divided by 2, which ends up just being 24 square root of 3. Okay? And now my height for my prism is the distance between the 2 bases. So the 16 represents the height. So I can plug it into the formula. B is going to be 24 root 3, area of the base, times the height, which is 16. And this is going to end up being 384 square root of 3 inches cubed. Okay, there's your volume. And then we had another problem asking us to work backwards to find the missing side, or the x, because it tells me we have a square base prism. We have the volume. Volume of any prism is BH. Because it's a square base prism, that means the square is the base. That means that basically my B is a square, and to find that I have to do x times x, which means B is x squared. So I know the height is the distance between those squares, which is 11. Since the volume is 396, I'm substituting that for V. So 396 equals my x squared times the height, which is 11. So first divide both sides by 11, and we get 36 equals x squared, and then we're taking the square root of that. So the x is 6. And here, working backwards again, says the volume of the cylinder is, with the height of 8 is 200 pi. Again, to find the volume of a cylinder is BH, but then you have to kind of ask yourself, what is the B? The B is a circle for a cylinder. So B would be pi r squared. So I'm just going to substitute that part in, and the fact that I already know what the volume is. The volume is this 200, so that's going to go in place of V. So 200, actually pi, excuse me, is equal to pi r squared times the height, and the height is 8. So we're going to solve for radius squared. To do that, I'm going to have to divide both sides by 8 pi. So I can get that radius squared by itself. Well, 200 divided by 8 will give me 25. And then when I take the square root, I'll find out that my radius is 5, which is what they want us to find. And then as for this last one, which is a test-like question, all of these are, by the way, we had to kind of get you to visualize, and I'm going to show you a couple examples of this on YouTube, using a system that maybe we'll get to. But if the plane, that means the square, the blue square, is revolved completely about the y-axis. That means I'm going around the y-axis as such, okay? But we're doing the whole space. Oops, that's a big circle, but we're doing this whole thing about the y-axis. And it says, if you were to, I'm needing you to realize that if you were to revolve this whole thing about the y-axis, that you would see, and this is not very good to scale, what would be formed, okay? And let's say you don't see it. This, so, you know, I'm hoping you see a shape that could possibly be created. But if not, it's okay. Let me go back, sorry. I'll help you with this a little bit. So, let's say, like, for example, this red rectangle is similar to, or it's a smaller version of our blue rectangle. So watch what happens if you rotate it around the y-axis. See what shape it's going to be formed. The green is another example of that. Rotating a solid rectangle about the y-axis. So you see that, hopefully you see that a cylinder will be formed in the opening inside of it too. This is no different than if you, because we're going to rotate about the y-axis, the x-axis, with looking at rotating triangles as well. So like if this gets rotated, and I showed just the area of that triangle being rotated, what shape would be formed here? Try to ask yourself what would be formed there. And I'm hoping you would see that a cone is formed, because you're going to see one of those as well. All right, so because we have a cylinder form on this one, what I wanted you to see, and this doesn't look very good, but oops. Oh no, why is it doing that? Oh, because it's not on. Sorry. Come on. There we go. Alright, so what I want you to see is that smaller compared to that larger. Basically, what we would end up having is we would have a large cylinder with the same base. This is kind of crooked. And then we would have the smaller one inside of there. And that would create basically a little opening in here. So to get the whole volume, we would have to take the volume of the whole, the large cylinder, and the volume of that would be pi r squared times the height, base times height, and we would have to subtract it from the smaller, the inner cylinder, okay? Pi r squared. Now, the thing you have to ask yourself, what would be the radius of the smaller one? The distance from the center here would be 1. So this would just be 1 pi, because 1 squared is just pi. But the radius for the larger would be 3. Okay, from the axis, because that's our axis of symmetry is our y-axis. That would be 3, so this would be pi times 3 squared. And then, oh, I forgot to put the height. So the height is basically our height of our rectangle, which is 4. So this actually becomes 4 pi. And then we have 3 squared times 4, which is 9 times 4 pi. So this is 36 pi minus 4 pi, which gives me 32 pi. All right, so that takes care of your notes. What I'm going to do is basically do a copy of what should have been in the spiral, basically what we have up here already written. That'll be in a PDF, and the video will be attached. So hopefully that gets everyone caught up. And the partial key has already been attached for the packet that you got last Wednesday. And then we will finish the packet you got today. Thanks.